All right, so here we go with the next one. This one's talking about functions. Here we will decide if a relation represents verbally, graphically, and symbolically define a function, and we're going to evaluate functions expressed in function notation. Vocabulary that you would need for this: function, discrete function, continuous function, vertical line test, function notation, and nonlinear function. You can usually find these on the textbook, the definitions. And you might hear me define them as I'm going through, but I'm not going to usually write them out for you. So anyways, let's see what we have here, and let's go. Okay, so I am going to give you the definition of a function. The definition of a function is that it is a relation in which each element of the domain is paired with exactly one element of the range. In other words, x does not repeat. When you look at a mapping, every single variable or every single number of the domain goes to only one number of the range. Like there's only one line coming off each. If you see two lines, that's not good. That's not a function. So just one line. If you look at a graph, you can do what's called the vertical line test, and you should be able to, let me see if I can do this. No, just grab this. And you can move this along, and right there, as you can see, as I move this along, it kind of goes across and does not touch any point on the graph, this continuous graph, more than once at any one given time. Okay, so it passed the vertical line test. If you look at just points, then it would be if any points above each other, that type of thing. So, and then a table, does the x repeat? These are things that determine whether or not it's a function. So basically, it's saying that for each x, there's one y. That's really what it's saying. For each independent, there's one dependent. Okay, so let's look at which of these are a function. Okay, so here are some examples. Some of these are functions, some of these are not functions. I would pause it maybe just so you could write all these down, because there's a lot here to write. And again, that's kind of the point with these videos. You can always pause, rewind, go forward, whatever. So, in the first mapping, is that a function? Well, we can see here all the x's, all the domains go to one y, each a different y, so that would be a function. You look at this table under it, none of the x's repeat, function. Look at the next table, you can see the y, the 3's repeat, so this is not a function. So I'm putting next there saying not a function. Check mark, function. X, not a function. It's wrong. Okay, you can see here on this mapping, this -3 I have going to 1 and 4, so it goes to two different y's. Not a function. No function for you. Here, on the next mapping, even though the 3 and the 4 go to the same 2, each of these x's has one line coming off of it. So that's a function. And the last one, the x's don't repeat, is a function. Yes, the y's repeat. That doesn't matter. It matters if the x repeats. So you can see which of these are functions and which of these aren't. Okay, so I decided to be a wee bit lazy, and I took a picture off the computer, off the PowerPoint presentation for this. There are three, so this is a word problem. There are three lunch periods at a school. During the first period, 352 students eat. During the second period, 304 students eat. During the third period, 391 students eat. So that means there's roughly about 1,000-something kids at this school. Not a big school. Make a table showing the number of students for each of the three lunch periods. So what we would do here, here's a table. Periods 1, 2, 3. Okay. Domain is 1, 2, 3. The range is how many kids ate the food. So you notice here, it's not possible to say in period 1 I had 352 students eat and I had 200 students eat. Not at the same time or something like that. So this is a function. For each x or each independent, there was one dependent variable or one dependent answer to it. Here's also the graph for this. Now, it doesn't make sense for me to connect these dots. These are three separate things because there was something that happened in first, something different than second, and something different in third. So this is three separate dots. So this is what is known as a discrete function. When we go point by point. Now, if I connected them for whatever reason, like that, then that would become a continuous. But it doesn't make sense here to say it's continuous. okay, because that would include the points in between. You have a first period or a first period lunch, a second period lunch, and a third period lunch. There's not a period 1.5 lunch. Okay, so this is kind of like that. Okay, the next one asks, is x equals -2 a function? Okay, we can represent this on the calculator, and if y'all ask me tomorrow to show you how to do some of these things on a calculator, I can show you how. X equals -2 is just a vertical line like this. It would fail the vertical line test because it's a vertical line, and a vertical line cannot be a function. So no, this is not a function. X equals -2 is not a function. We can represent it, but it is not a function. All right, let's do one in orange. How about 3x plus 2y equal to 12? Now, I can show you how to do this on the calculator, but I'm just showing the graph. We'll talk about how to do these types of graphs later. But we connect those two dots, and yes, it is a function. It would pass the vertical line test. If I take a vertical line, let's see if I can do this again. You can see here, as I go across, it never touches the line twice. The line never touches the vertical line. The graph never touches the vertical line twice at the same time. But if you look here, even though my thing is drawn horribly, it is. So that's why that one failed, but this one passes. Okay? So there we go. Function and not a function. So here's another picture, summary representation of functions. Table, x doesn't repeat, mapping, each x goes to one y. You can have it as an equation, like f of x. This is what is called function notation. We're going to talk about that more later. And then a graph. Okay, so let's talk about function notation. Okay, function notation is a way of showing a function in terms of the independent variable and a rule. Okay, that's kind of my short way of showing it because my electronic book wasn't working and I kind of wanted to get to that, but we were having some problems here. But that's kind of like what we can do there. Let's see here. Let me see if there's anything different here that I would want to say, but I think that's okay. I don't think that's going to work. Never mind. Okay, not going to happen. Anyways. So here you have what is called function notation. Now notice, this is saying f means function. A function of x in terms of x, so they're identifying the independent variable, is equal to 2 times x minus 7. Okay, so here's my rule. This is my rule. What a rule means is like the equation, what we use to evaluate. Your x is your independent variable, but the whole thing, f of x, is your dependent variable. Okay, so f of x is considered dependent, but they're telling you in the parentheses what's your independent, what you can put in to get an answer out. Okay, input is your independent, output is your dependent. So let's look at an example. Let's evaluate a function in terms of, function and function notation. So here's f of x equals 3x minus 4. Find f of 4. Okay. So this is the way this question can be asked. Notice function notation. All they're saying is, notice how the 4 is in parentheses. So I can put that 4 in place of any x I see. So 3 times 4 minus 4. Press enter or type it in. 12 minus 4 is 8. And thus, when when the x is 4, then the answer is 8. And I can show that as an ordered pair, 4, 8, where this is the x and this is the f of x for that one situation. Okay? The next one, f of t, I decided to change up the variable, negative 4t plus 7. Find negative 3. So I put negative 3 in place of the t. Very simple example. I get 19 for an answer, and thus we've got that. T, f of t. So that's showing you some quick examples with, say, determining if something is a function, if it's not a function, what's a variable, what's not a variable, that type of thing. If you have any questions, feel free to ask. But that's it for today. Thank you very much.